All right. So triangular distributions will be our last distribution that we're going to be talking about. And then we have a few other little details to clean up when some odd things happen and some other questions that can be answered using statistics. And I wanted to talk about those after we get all the distributions out of the way. So, things you need to know about triangular distribution. First of all, it is a continuous distribution, meaning that the probability that we'll be measuring, so probability is equal to the area. Right? So we did these, that's the same as the normal distribution, and it's the same as the rectangular distributions that we looked at, right? So they're continuous over a specific area. And finding that area will give you the probability. You will be given 3 parameters. And again, parameters just means the information they're going to give you to know what distribution you use, the type of distribution it's going to be. You're going to be given a minimum, a maximum, and a mode. Do you remember what mode means? It's the thing that occurs most often, most common, yeah. And you're often going to see this described not as mode, but as most common, most often, etc. So you're going to see it given as a phrase instead of saying the mode is. Okay? So think about what happens when you have this type of distribution then. We have a minimum value. We have a maximum value. And somewhere in here, who knows, we have the mode, which is the one that happens most frequently, which means that's going to be the tallest point of the distribution. Guys. So if you have a minimum here, a maximum here, and a mode here, and you connect those dots, what shape have you just created? Triangle. And that's why these are triangular distributions. They're almost worthless in the real world. But they can model things that don't really exist, and that's usually how they're used. But then that makes you so happy. But you don't care. All you need to know is how to use it. This one is the most formulaic of all of them. You don't have to memorize any formula, though. But it does mean you have to do a lot of picky little addition, subtraction stuff. Okay? So the formulas for all of this will be given. So let's talk first about the steps for working with this. Okay? To find the area, which again is the same as the probability, the first thing you have to do is find the height at the given point. And this part is where you're going to use the formulas. And we're going to look at those and look at the formula page to show you. Because it's a different formula depending on where you are in the triangle. Because if you think about it, the first part of a triangle is going up, so it's increasing. But the second part of a triangle is going down, it's getting smaller, right? So the formula you're going to use is going to depend on where your value is on your triangle. Does that make sense? Okay. Second, after you find that height, then you need to remember that the area of a triangle is 1/2 times the base times the height. Right? Which is why we had to find the height before we could do this problem. The base is simply the thing on the bottom. The base is easy. So for the whole triangle, the base is simply the maximum minus the minimum. Right? One end minus the other end. So you can find the base there easily. Okay? But for any given triangle, you just make sure that you're always subtracting the largest value minus the smaller value. Make sure you get them in the right order, otherwise you're going to get a negative, which you're going to immediately know is not correct for your base anyway. You could do them in any order, and then you would just change the sign. Okay? So the basis is easy to find. You just find that with some subtraction. But the height is going to be found using a formula. And now, you don't have to memorize any of these formulas. You don't even have to remember area is 1/2 times base times height. That's on your formulas page 2. And so we're going to look at the formulas page, and then we're going to look at one of these because we want to see how they're labeled and make sure that you understand where all these numbers are coming from. And then it's just a matter of simplifying and then putting it into solver once you have it simplified to find your missing value. Okay? So here we are. So again, continuous distribution, meaning that it goes from end to end and the area is always the probability, right? And it's going to take the shape of a triangle where you have a maximum, a minimum, and a mode. So look at the example they give you. The length of time for a bus trip is between 22 and 27 minutes. So we know the shortest amount of time it can take, and we know the longest amount of time that it can take. So therefore, that's the maximum and the minimum. With a most likely time of 25 minutes. Well, most likely is the same as saying the mode. So do you see that they very rarely tell you the minimum is, the maximum is, the mode is, but they give it to you in phrases where it's pretty easy to understand. You're not going to have too much trouble pulling the right information out of these. That's not usually an issue with these. Usually the issue with these is not being extremely careful in these complicated formulas. All right? Now, I'm not going to derive the formulas for you. I'm just going to show you what they are, and so we can ignore all of that. You don't really care where they came from. You just care about being able to use them. And you're not going to be asked any questions about where they came from. So let's look at the labels then. Right? So here is an example of a triangular distribution. And they always use the same letters, and you need to make sure that you're using the same as well. The minimum value is always labeled A. So you see label A for the minimum value. The maximum value is always labeled B. So you see that's there. And the mode is always labeled C. So that's the highest point, which is right there. Now, be careful. The tendency is to want to do things in alphabetical order, right? But C is always in the middle. C is the mode. So be careful that you label these correctly so you see what you're going to be using, right? We're not interested in that bit. We're not interested in that bit. We're very interested in this part because we have to find the area that is the probability. And we're also very interested in this part. Now, again, though, they're going to tell you that. Another part of labeling that you need to be familiar with is they're going to call f of x. F of x is always the height. So in this case, they give you a formula for finding the height at C. Okay? Now, this formula only works at C. If you move away from the mode, then you're going to have to use something different. Okay? But the highest point for this triangle, you can find the height by putting 2 over b minus a. And then simplifying it. Now, that's not usually the height that you're going to be looking for, though. Generally, they're going to tell you, so some value here. They'll give you a value. So that means we need to find this area, which means I need the height here. Yeah? And you can't find that by using that formula. There's going to be a different formula for it. Okay? So this was only the height value for C. Okay? Now, on your formula sheet, you're going to see the formulas for the rest of them, though. So let's just talk about those. Don't worry about that bit. Let's see if they give me the whole formula sheet. Hold on. All right. So first of all, the first formula is for finding what's happening on this side of the triangle. And again, it's that side of the triangle because we're going up. So that's this formula. Notice you have an x value. That's your height at a given point, and so sometimes you'll be given that, sometimes you won't. We have A. A is always the minimum value, doesn't ever change. We have B, which is always the maximum value, doesn't ever change. And then C, always the value of the mode, doesn't ever change. And then A again. You will, again, do not have to memorize these. They will be given to you, but you will have to use them over and over again. And you'll find that the hardest part is just staying focused and organized. But be careful, right? Now, here is what happens when you're on this side of the triangle. Because on that side of the triangle, the areas are getting smaller, yeah? So it needs a different formula. And you see it's still B's and A's and C's and then your next value. They're just in slightly different areas, different positions, because this time we're measuring the slope going down. These formulas come from the fact that you're sloping up or you're sloping down, which changes the area you're looking for. There will be times when you're going to asked to find the area of positions like this, and we'll talk about that in just a moment too. But for now, we're just going to look at the triangle. Okay? And that's why they give you the area of a trapezium. Because remember, a trapezium looks like that. So that formula could be used if you need two pieces. Now, there's another way you could do that if you don't want to remember, because the area of a trapezium is not given to you. But if you think about that particular shape, if it's there, then that's a big triangle minus a smaller triangle. You could find the area of the two triangles and subtract out the one you don't need, the part you don't need. So either way you want to do it, or you can just memorize this formula. So be prepared. If you do, they're not going to give you this formula. So you can treat it as two different triangles, subtract out the smaller one, perfectly acceptable. So you get a choice there. Now, think about the other ones. They may ask you, and I can't imagine they're doing this, but the rest of the space and on your formulas page, the very first of this, so they're calling it f of x. Again, f of x in this case always means the height, right? And the first one they give you is 0. And the reason it's 0 is because it's over here outside of the triangle. So anything before A is going to be 0. And then at the bottom, they give you another 0. That's referencing this area outside of the triangle. So for example, in that bus thing, the maximum was 27 minutes. So what if they ask you, what is the probability that you were on that bus for 35 minutes? It's outside of our range, so it's going to be 0. Okay? Now, you'd want them to give you that because it'd be easy. There's no math involved at all, but it would be 0. And then you're going to have the first formula is for going up the triangle. That's this one. The second one on that page is this one. Okay? So when you're going back down. So again, pay close attention to which direction, where the triangle is. Do your shading first, always, just like on all of the other distributions. Okay? Yes, it'll look just like that page. Mm-hmm. Yeah, even has the drawing of the triangle and telling you where A, B, and C are. Okay? All right, so let's just look at an example, and then you're just going to do these. There is nothing tricky about these. You just have to make sure you're putting the right number in the right spot. Now, there is another trick to this for those of you who have some geometry or trigonometry knowledge. Have you ever heard of the phrase similar triangles? If you're comfortable with similar triangles, I'm happy to show you how you could use those instead of the formula. But if you use similar triangles, that means you're using everything out of your head the whole time. Now, if you're comfortable with that, it's faster. If you're not comfortable with that, it's a disaster, okay? So you decide whether you want to use formulas or similar triangles. I will do another lesson with that. With those of you who want to see it, I'll show you how that works in just a moment, okay? It's just setting up a proportion, so it makes it just cross multiply. It's very easy, but you have to know what you're doing, okay? All right. But for these examples, we're going to use the formula. So let's see. Here we go. The length of time for a bus trip is between 22 and 27 minutes, with a most likely time of 25 minutes. Draw the distribution, label the scales, and show the values of any intercepts. So You'll see that they've drawn this as a triangular distribution because we had a minimum, a maximum, and a most likely, which is a mode. So minimum here, maximum here, mode here, which is just the point of the triangle. And notice that they put the 25 closer to the 27 because 25 is closer to 27 than it is to 22, right? It's a sketch. No one's going to, this one has a scale on it. So you should, and the other ones you look at should have as well. So try to get it as close as you can. So pay attention to the scale and get the shape. Because if we didn't know exactly where that mode happened, we wouldn't know when to switch from Formula 1 to Formula 2. Okay? So draw these as accurately as you can. Now to find the height at the mode, that's just that 2 over b minus a. So they've done that. 2 minus b, which is 27. B minus 20, minus your a, so 22. So that gives you the height, and they give it to you as a decimal. Okay? But that is only how to find the height at the mode. You're always going to need those numbers, though. Okay? Especially if you're going to use similar triangles. So do you see where all those numbers came from? It's just a matter of plugging it in and going. You don't have to memorize any of that. Now let's look at the question. Calculate the probability. Hold on a second. Calculate the probability that a bus trip lasts between 26 and 27 minutes. So the first thing we want to do is we want to shade the area we're looking for. So 26 minutes is here, and between 26 and 27, so that's our area that we're looking for. Yeah? This time they know they've given us the value we want, and since that's the new value, that's your x value. Yeah? Just like every other probability we had, x is the one that you didn't know, or the new probability, the piece. Again, these stay B, A, and C. So we're on this side of the triangle, so that's why they've picked this particular formula. All you're doing is plugging in the numbers. 2 straight from the formula. Our B was 27. Our X was 26. Down in the bottom, that's a B. That's an A. That's a B. And that's your C. Again, you don't have to memorize each one of those, but you have to put them in the right spot. Then you're just going to simplify the top, simplify the bottom, and you've got your area. Okay? Which is also, and your area is equal to, you got your height. Okay? So this is your height. So since you have the height, then you can plug in the information you need into the area formula. So 1/2 times your base. How do you find your base? Maximum minus the minimum. But in this case, we're just looking for this little triangle. So we're going to take the biggest value, this side minus this side. So 27 minus 26 gives us a base of 1. We found our height. So 1/2 times 1 times 0.2. Just plug those into your calculator, and it will give you your probability of 0.1 in this case. So remember, first step is just finding the height. Then you're going to use the area formula for a triangle to find your actual area. Super easy? Yes. Okay? Now, the only time it could get harder than that is if they give you the area and then you have to find the x value that goes with it. Which means that when you plug all this stuff into this formula, you're going to have you're going to have one of your values is going to be an unknown value in there. But that's okay. You can just plug it into Solver and it can solve the unknown. Get it simplify it as much as you can. Do all the math you can to simplify it, and then plug in the value. I don't know if they give you one like that. Let me just look at it real quickly. Here's one where they have between. And again, you have two options here. We could find the area of this triangle, find the area of this triangle, and subtract the small one from that big one, and it'll get rid of that area. Or you can find the height and then use the formula for an area of a trapezium, but this formula is not on your formula page. Only the triangles. Okay? So either way you want to do it, how would you think you do it? two triangles and subtract them, or do you think you're just going to take the time to memorize the trapezium formula? Probably two triangles and subtract because it's all there. Doesn't matter. You get the same answer. Yes? Can you see that that's just a big triangle with another little triangle subtracted out of it? Okay. All righty. So let's look at one together. The graph shows a triangular distribution. Write down the parameters for this distribution. So in other words, I want to label my A, B, and C. Well, A is always the minimum, B is always the maximum, and C is the one that occurs most frequently. In other words, the top of the triangle, so that one. So what is A in this case then? 1. Good. B? And C?
3.
There you go. Always remember they're not in alphabetical order. C is always in the middle for some reason. Okay. The maximum height for this distribution is f of 3. F of 3 because C is 3 is 0.4. Show how this value was calculated. Okay. Well, how do you calculate the height at C? There's a formula for it. It's on your page. F of x is equal to 2 over b minus a. Right? So, f of 3, because 3 is the height I'm looking for, is this plate where my x is, my value, is equal to 2 over 6 minus 1, which is 2 over 5, which simplifies to 0.4. Yes? I don't know. If you do the math. Y'all have the calculators, I don't. Somebody want to confirm that 2 over 5 is 0.4? Now this one's very straightforward, but what if I got a number here and it wasn't the same? Then I can dispute what they say, and that's a favorite NCEA trick. They'll give you something wrong and then say what's wrong with it, right? They love those questions. Sally said that the height of this thing is whatever at C. Is she correct? Well, you have to put it into the formula and find out. Test it. It's easy to do, okay? And so these are going to get ugly, but yeah, just deal with it. Stay focused. Okay. In order to calculate the probability that x is more than 5, you would need to know the triangle height of f of 5, which is 0.13. How is this calculated? Okay, let's go back to our triangle and do some drawing. They never like to ask you things that are just straightforward. What's the area, do they? All right, so this time we're looking for more than 5. Well, here's 5. More than 5 means go to the end, right? So it's this area here we're looking at. And they're telling us that the height, remember height is always defined as f of that number, f of x. They're saying that that height was 0.13. Is that right? Yeah. Okay. How did they come up with that? Right? Which side of the triangle are we on? The right-hand side. So is that the top one on your page or the second one? It's the second one. Can you read it to me?
2 bracket b minus x over b minus a b minus c.
And again, you don't have to memorize those. You just have to know how to use it. So let's just plug in the values. So it's 2 times, our b is 6. Our x in this case is 5, right? Because that's our limit here. Okay? B minus a is 6 minus 1. B minus c is 6 minus 5. See where I'm getting all that crap stuff? So well. Don't play this recording to your parents. Okay. Oh, that's the worst thing I've ever said. 6 minus 5 is 1, which gives us a 2 in the top. 6 minus 1 is 5. Guys, shh. 6 minus 5 is 1. 5 times 1 is 5. Two over 5 is what? Yeah, that's the same one we just got. So what happened?
Is the formula...
Okay. I used the wrong C. It's 3.
Is the bottom on the right side?
So that's a 3 right there. Yeah, the bottom one's the right side. So we're using the right formula. I just put in the wrong number for C. So 6 minus 3 is 3 there. So 5 times 3 is 15. 2 over 15. Okay? Use the right number in the right spot. That's a teachable moment, yes? Okay? I just used the wrong number in place of C. I used my X instead of my C. Okay? Yes?
In the equation, so what do we put for if of x? Or do we just do fraction?
No.
Equals?
You wouldn't put any of that. You would, if you're going to use, well, this one's not really about solver. This is just your math. So you wouldn't use solver for this. The only time you would use solver is if you didn't know that one of the variables. Well, that's when you don't know one of the variables, right? Then you would use solver. But otherwise you don't. Now you could put all of this into your calculator, but if you did, that's just the regular math menu. And then you would put 2, bracket, 6 minus 5, bracket, fraction key. It's horrible. Just do piece by piece. And you can still use your calculator if you want to. But notice the numbers stay they're not terrible, right? You're just doing a little subtraction. But if you didn't know one of these, that's when you would use solver. Okay? All right? Now, or you could put it f of x, you could put that as your unknown, because that's what you don't know. You could put that as x and plug in everything else into solver. But again, it's really ugly. So you'd need brackets inside of brackets to make to do that. It's bad. Okay? Try to avoid it. Okay? So to actually find the area of this, or the probability, remember we have a height of 0.13. I need a base. What's 6 minus 5? 1. So it's 1/2 times my base, which is 1, times my height, which is 0.13. Somebody want to multiply that out for me and give it to me as a decimal, please? Now, 0.065 is what she got. So, and they have just 0.06 because they didn't round anything on the way there. You're going to find on these that there are usually rounding errors. So if you get close to it, you're okay. All right? Okay. Because there are usually rounding errors in these. Don't panic too much. Okay. All right. So then they're just going to give you more pieces. Again, it's just about plugging into the formula. All right. So I'm going to set you free with these. They start on page 104. And then just keep going with these until page... And look at this one. This one is one where they have the approximate. Okay. Page 108. Now, if they ask one where they want the mean of it or the median of it, sorry, it's usually median, the median of them, then stop and mark it and we'll come back to it. Right? I'll come back to that tomorrow.